Pittsburgh, the Steel City, once the epicenter of American steel production, with countless mills and foundries lining the city's landscape. It was the largest steel producer in the world. But the days of heavy industry have given way to a new era of innovation, and modern technologies are blossoming. Just like those early days of the steel industry in Pittsburgh, today's cutting-edge innovations are characterized by innovation and hard work. Backbreaking labor has been replaced with computer-aided sustainable technological advancements in manufacturing, utilizing novel design freedom that has enabled concepts to come to fruition. Ladies and gentlemen, we proudly present several cutting-edge innovations that are the winners of the 2024 Powder Metallurgy Design Excellence Awards competition, sponsored by the Metal Powder Industries Federation. Let's start with the awards of distinction. APG Sintered Metals, a division of Nichols Portland Incorporated, received an award of distinction in the automotive engine category for conventional PM components for an injector flange assembly. This diesel exhaust fluid injector flange assembly is used in a mid-size pickup truck to reduce the amount of nitrogen oxide gas exiting the tailpipe. Austenitic 304 stainless steel was selected for its combined good corrosion resistance and weldability. Due to the low compressibility of the powder, the parts are sintered at 1350 degrees Celsius in hydrogen to reach the final 7.0 grams per cubic centimeter density. Minor machining is required on the inner diameter and conical counterbore. After welding, the assembly does not leak when under pressure. AAM Subiaco Manufacturing Facility received an award of distinction in the automotive engine category for conventional PM components for a camshaft position sensor exciter wheel. Mounted on the camshaft of full-size pickup trucks and sport utility vehicles, the position sensor exciter wheel assists the cam sensor to input data to the engine control module to determine the camshaft position and velocity. The FY4500 iron phosphorus alloy has good magnetic properties, and only a turning operation is required to create the precision, thin-walled mounting hub and face. The PM process has better material utilization and precision compared with stamping, and the parts are acceptable for recycling as they do not contain copper. Indo MIM Limited received an award of distinction in the automotive engine category for MIM components for a turbocharger lever. This lever is used as a gas flow controller in the turbocharger of an internal combustion engine. Originally specified as an HK30 austenitic stainless steel, the parts are made using MIM 17.4 pH precipitation hardening stainless steel and proved satisfactory for the application that requires corrosion resistance and high temperature properties. MIM processing reduced lead times and was able to produce the high volume of parts needed weekly by the customer, while significantly reducing waste material compared with the forging process. Metalpo Industria Ecom Ltda and customer Norbremse received an award of distinction in the automotive chassis category for conventional PM components for a steering column tilt adjustment component. Understanding the application to define the best fit between geometry, process, and requirement enabled a best cost benefit for this truck steering column tilt adjustment component. When carbonitrided PM part was unable to meet the dimensional tolerances, the material, design, and process were changed to a sinter-hardened FLC 4908 component with a density of 7.0 grams per cubic centimeter. Changing from traditional carbonitriding to sinter hardening reduced the carbon dioxide emissions by 156 kilograms. Hangzhou Sino MIM Technology Company Limited received an award of distinction in the automotive electric vehicle category for MIM components for a ratchet shaft. Used in the parking brake system for new electric vehicles, the ratchet shaft engages a cam to lock the disc brake when parked. The chromium molybdenum alloy steel has a tensile strength of 1400 megapascal and a yield strength of 1200 megapascal. Although the ratchet shaft requires minimal machining, the MIM part resulted in a 20% cost saving compared with a fully machined component. Azoth and customer General Motors received an award of distinction in the automotive electric vehicle category for metal AM components for a seatbelt pillar adjustable guide loop. This seatbelt pillar adjustable guide loop was designed with binder jet AM processing in mind and includes a complex internal channel to reduce mass and material waste. The surface of the parts is semi-automatically polished prior to a multi-layer bright nickel chrome plating operation to improve corrosion performance and provide a hard, scratch-resistant resistant surface. Parts are tested for cyclic corrosion resistance, thermal shock resistance, perspiration resistance, and resistance to cleaning agents. Prior to using AM processing, the component was an assembly of 4 separate parts. Hangzhou Sino-Mim Technology Company Limited received an award of distinction in the electrical components category for MIM components for an optical communications module bracket. Used as a heat dissipation module in an optical communication 5G base station, numerous heating components are mounted on the bracket surface, which serves not only as the mounting base, but also conducts and dissipates heat. This ultra-thin base plate has a flatness requirement of less than 0.03 millimeters. MIM processing cut the product cycle time for this electroplated 50-50 copper tungsten bracket while reducing the cost by 45%. Hangzhou Sino-Mim Technology Company Limited received an award of distinction in the electrical components category for MIM components for an aluminum alloy smartwatch case. The thin, complex sections of this aluminum alloy smartwatch case require use of a high-fluidity feedstock and a high-speed molding machine. The curved surface of the watch cases necessitates manual polishing to a mirror finish, and the parts are anodized to various colors. The lightweight of the aluminum alloy case, compared with ones made using stainless steel, is a significant benefit. The MIM technology has high material utilization and the advantages of lower cost over machining. Capstan received an award of distinction in the hand tools recreation category for conventional PM components for a main drive gear. This 3/16 stainless steel main drive gear is used in a throttle system with a stack-up of 3 stainless steel PM-driven gears. The compaction process achieved about 60% of the final shape of the part, and secondary CNC lathe turning and milling operations were used to achieve the bore depths, hub diameter, groove, and tapped hole. The PM part had a keyed form built into the compaction tooling, a distinct advantage compared with the previously machined wrought component. The finished gear is a 9-level part, made to an AGMA 7 quality level. APG MIM, a division of Nichols Portland Incorporated, received an award of distinction in the hardware appliances category for metal AM components for pneumatic chuck jaws. Compared with traditional work-holding chuck jaws, these lightweight jaws offer an 84% reduction in rotating mass and a fraction of the centrifugal force that the pneumatic chuck must overcome at full rotational speed. The lower centrifugal force requires a clamping pressure roughly a third of what a traditional chuck would require. Made using the material jetting process, the inner lattice structure is formed without having to depowder, eliminating the risk of free powder entrapment. The process generates little waste, and the wax used to form the mold is recovered and can be reused for a future build. Phoenix Sintered Metals LLC and customer Muncie Power Products Incorporated received an award of distinction in the industrial motors, controls, and hydraulics category for conventional PM components for a piston brake spring return assembly. Used in a power takeoff system in work truck applications, this unique design piston brake spring return assembly engages the clutch pack under pressure, and the taper feature acts as a brake when disengaged. Both the piston and piston cup are made from FN0208 at a density of 6.9 grams per cubic centimeter. The ability to form the tone ring feature on the inner hub of the piston was a feature not available on the prior part design that was machined from bar stock, resulting in excessive scrap and machining cost. Indo MIM Limited received an award of distinction in the industrial motors, controls, and hydraulics category for MIM components for a control cone. This control cone acts as a fluid controller in a fuel pump. Made with AISI 9310 low alloy steel, the intricate profiles of the part have tight tolerances that were difficult to maintain when produced by machining, and much more costly. Repeatability and precision are key attributes of the MIM process, along with high volume manufacturing and shorter lead times when compared with the machining process. Capstan Atlantic and customer Artisam Incorporated received an award of distinction in the lawn and garden off-highway category for conventional PM components for a multi-component gear assembly. 7 different gears are used in the assembly of the transmission for a rear-style garden tiller. 6 gears are made using FLN2 4405, and the 7th, a bevel gear, is made using a copper-infiltrated PM steel. All are carburized. A special heat treatment cycle was developed to maintain hardness, but also also maximize ultimate tensile strength and impact energy. The conversion of 7 gears from wrought steel to PM reduced the amount of scrap produced by machining and had significant cost savings. Metco Industries Incorporated received an award of distinction in the medical dental category for conventional PM components for a latch lock assembly. 2 distinct PM components are required for this 9-part assembly that is used in a heavy-duty hospital bed rail lock latch assembly. The latch lock lever is made using FC0208 and requires controlled density on the ramp, which is a critical wear zone. After sintering, the levers are milled, heat-treated, and zinc-plated. The saddle parts are a copper-infiltrated PM steel, providing a safety factor for a strength and wear resistance, and zinc-plated to provide a sterile surface unlikely to absorb contaminants in a hospital environment. Azoth and customer Surset Connect LLC received an award of distinction in the medical dental category for medical AM components for electromedical connector components. These electromedical connector components, a set screw block, and a spring housing mate with the associated catheter and provide mechanical feedback to the surgeon, ensuring proper insertion of the catheter in the patient. The material jetting process was selected for the 316 stainless steel parts to meet the complexity, high resolution, and good surface finish that was required. It also enabled the manufacturer to test and evaluate multiple design variations quickly, making it easier to identify and rectify design characteristics and performance improvements. PTI Tech received an award of distinction in the military firearms category for MIM components for a bolt weight. To reduce the raw material cost for this tungsten heavy alloy inertia weight in a bolt assembly for a blowback firearm, MIM was selected as the solution. A 95% weight tungsten alloy was selected to result in a relative density of more than 18 grams per cubic centimeter. Sacrificial support ribs were added to mitigate sintering distortion and were CNC machined from the final part. Machining the part from bar stock would have resulted in over 70% scrap, considering an 1,100 gram bar stock would be machined to a 250 gram finished part. ARC Group Worldwide and customer Halo Ammunition received an award of distinction in the military firearms category for MIM components for a .45 caliber bullet. This .45 caliber bullet is a solid copper projectile that uses a feedstock that contains 99.8% copper, along with a proprietary binder formulation to ensure even and complete sintering with minimal distortion. The petals were redesigned for better suitability in injection molding. The part sinters to 96% relative density with minimal distortion. Machining is not required, and scrap from tool setup can be recycled. Ladies and gentlemen, these are the winners of the Awards of Distinction in the 2024 PM Design Excellence Awards competition. Please join us in acknowledging their achievements as company representatives accept their awards.